So let's do the area between graphs first, because it's a recent topic and I think people stuck with this. For example, number 10 from your homework. Area between graphs will show up 2 or more times on the test. This is the last topic we covered. So the last one is average integral, but still. Area between curves or graphs, curves or functions, graphs, and so on. So, for example, y equals square root of x. What else was it? I immediately forgot. X-axis and x equals 0 and x equals 25. X-axis, x equals 0, x equals 25. So you was asking me if I'm gonna give you the graph. I just checked with the coordinator. Once we're gonna give you the graph, and the other time we will not. So you will have to use your graphing calculator, or you know how the function looks like. And I gave you a very classical function, either a square root or x squared, something very clear. Y equals x. So y equals x is a classical. Y equals x squared. Y equals square root of x. This one we assume you know them, so we always give it to you. But you have graphic calculator, so it's also not too scary. Square root of x. At 0, it is 0 and slowly growing. X equals 0. What's the other way to call line x equals 0? So this is y equals square root of x. X equals 0 can also be called y-axis, right? So that's x equals 0. X equals 0 and x equals 25 are two vertical walls cutting this shape. Now it's x equals 25. So x equals 0 and x equals 25. But then there's also one horizontal wall, which is x-axis. One way to recall what x-axis is to call it y equals 0. X-axis, y-axis, and then y equals to 0. And this is the area. I will go a little bit fast today because all of this is a review, but stop me if you think I should explain better. Definitely stop me. The main idea is to plot the integral. Write down the integral and then you solve it. So step 1, sketch the graph. Step 2, start thinking how the integral will look like. The integral looks like from a to b, function at the top minus function at the bottom, dx. Area, function at the top minus function at the bottom. This is the formula you need to remember. Do you remember that? So, I already visually can see which function is at the top. Function square root of x is at the top, so it will go first, minus y equals 0. That is the second one. But I need to find a and b. From this example, a and b are obvious, 0 and 25. But if not, you need to find points of intersection, and I am asking you on the exam to do that. So, find points of intersection. How to do that? I need this point and this point. The first point is 0, but the second point, which I can see is 25, it's just a 25. You create a system of equations, y equals and y equals. I will give you one more example where we actually have to do that. Step 3, you finish the integral. A is from 0 to 25. X is from 0 to 25. Square root was at the top, and so that's the top one. And this is how it looks like. Y equals square root. Y equals, who is at the bottom? 0. Dx. This is the crucial part. If you understand how this integral was built, this is lots of points on the test. Lots of, like 20 points at least.
Why is it 0? Okay.
So this is the most important part. I was wondering if people are gonna ask. Look visually at this area. How does it bound How does it bound from left to right? That's my A and B. A is 0, B is 25. That goes to the integral sign. And then from top to bottom, square root of x minus 0, square root of x minus 0, square root of x minus 0. Why? Because square root of x is at the top and y equals 0 is the line at the bottom. So this is how you should see it. So that actually is square root of x minus 0. More ask me, how did we create this integral? This is like the most crucial part. What do you think? Yes?
So confused on how you found the y0. Is it like the y-intercept? Or like, how is...
It's like this. Let me try to explain this way.
Like, what if you had another example? Like that one, I see it goes over 0.
Yeah. It's whatever function is at the bottom. So even if it's not 0, it will be different, which I have second example to show you. Yeah. But we have this one 0 because it said x-axis. So x, oh, let me write this down. That's actually a good note to make. Note, x-axis can be called as y equals 0, and y-axis can be called as x equals 0. It's always the opposite. So this is what I used to create this equation. They said x-axis, and I like, oh, that's y equals 0. And that will be the floor of this area. So find the ceiling and find the floor, and you do the ceiling minus the floor. And I'll have one more example. That's a good idea to do. And now you integrate. So I will rewrite it like this. Square root of x dx from 0 to 25. Agree? And now you need to integrate that. What is the integral of square root of x? X to the 1/2, and now you integrate it. So take your pencil and write it down as x to the 1/2. And now you integrate, add 1, divide by that number. So x, 1/2 plus 1 is 3/2 over 3/2. I would divide by 2/3 right away. From 0 to 25 equals 2/3 multiplied by 25 raised to 3/2. This is the final answer. I do see they simplify it in homework, but it is actually good. But I do know how to simplify it. It's 5 squared cancels out with a square root and blah, blah, blah. So this is the final answer though. Questions? Yes? I will do a different example, yeah, which is more interesting than this one. Good homework example. That was from your homework, yes?
Where it was like, I don't know, there was one other review where you had to like subtract something, or because there's like 2 different parts of the graph and you had to...
Yeah, I will do that right now. I have this one in mind. So this is a good one. Good questions, people. Area is that topic that has lots of steps, and that's why you need to practice to remember the steps. But basically there's 3 steps. Sketch the graph, find points of intersection, build the integral. And the last step, if we ask you, you actually solve it. Find the area bounded by. BDD means bounded by. And then I will have y equals x squared, y equals 4, and let's see, and x equals 0. Who is talking too much? I can hear you. I can hear you, but I won't. You look for trouble. I know. No, but did you recognize my Frozen song? That was a good joke. Okay, fine. That was a good joke. My engineering students did laugh when I said it, so like always check different sense of humor. Solution. Here it is. So we're not gonna give you the graph. Do you know how parabola looks like? Looks like this. BDD bounded by. So find the area bounded by. Bounded by. I will not put this word on a test, but it's nice in the notes. It's just fast to write it down. Area bounded by. Y equals x squared. Typical parabola. Y equals 4. That is a ceiling. Y equals 4. X equals 0. That is y-axis. X equals to 0. This is the area. How about that? How to find the integral for this area? Step number 1. sketch the graph. Step number 2, find points of intersection. I need this point, but it is 0. And then I need this point, and I don't know what it is. So I have to solve for it.
Yes? Not the other side of that shaded too. The other side.
Good question. Let's call it only positive. Oops. That is a good question. The question is why we're not counting this one. Usually people just know let's use the first quadrant. If you want, I can put x is bigger than 0. Oh, if you put this note, then it's only one side. Yeah, don't worry. On the exam, I'm not going to make it that confusing. But this is a very good problem. So, system. You create a system. Let's just create it. Y equals x squared and y equals 4 to find points of intersection. Points of intersection. How to do that? You solve system of equations. 4 equals x squared. You kind of plug it in, you know. 4 equals x squared. Solve that. X has 2 solutions, plus and minus 2. But we only need 1. Visually, I can say to this one, and this is how you find a point of intersection. Can you do that? Looks not too bad, yes?
What would you do if the y was like y equals -1? Because I know we had a problem like that on our...
Yeah, it should be different function then, but I think it's like this. The question is if y is negative, but then it should be like some kind of more restriction to create the area. Maybe it was like this or something like this. It should have more restrictions then. Still, you find point of intersection, and point of intersection might be negative. That's probably what your question is. If this point is negative, good for it, you know, let it be. So, no difference. Find the ceiling, find the floor. So let me write down the integral, and I will have more questions coming. What is the ceiling? Y equals 4 is the ceiling. What is the floor of this object? X squared is the floor. Y equals x squared. So the integral will be, let me build it, and then you can ask more. From 0 to 2, we found 2 from points of intersection. Ceiling, y equals 4, you just put 4, minus the floor, y equals x squared dx. This, if you can build this, it gives you lots of points already. What do you think about this? Yeah, questions? No, good. You can think more. No rush. Yes.
So what about like the one like on the number 26? You probably need 2 different integrals to answer.
Yeah, I'm not gonna put a different integrals. Are you kidding me? But yeah, I feel your pain. 2 different integrals is a bit too complicated. For homework, I guess it's fine. For test, too long. Yeah, it will be this very, very straightforward. And there will be several, but they will be very straightforward, nothing too complicated. Find points of intersection, build the integral, integrate. Done. Yes?
What's the point of the graph if you end up just using the equations given?
Good question. Without the graph, you don't know which one is higher, which one is lower. For example, that's a good question. Why do we need even the graph? Actually, on the exam, I don't remember saying that I will give you points for graphing it. Maybe I should. But if you can guess without it, good for you. But if there is a y equals minus x squared plus 5, this thing will look like that. And then, now who is at the top? The parabola is at the top, line is at the bottom. So technically speaking, graph should help you to figure out who is the ceiling and who is the floor. Yeah, but I mean, she's right. If you can guess it without the graph, good job. Just don't always assume that the first one goes up. Yes? Yeah, we always put first, which is lower on the left, and then the one on the right. So 0 goes here, and then 2 goes here. That's a good question. Yeah?
For the area equation, I should have put 4 first.
The one at the top. The one at the top, that's why I call it top, which is basically, so imagine this is an object. You're a civil engineer, for example. You're building a house. This is an object. It has ceiling and it has a floor. And that's exactly why we're teaching this, because it has lots of applications. What is a ceiling? I'm looking up. It's y equals 4. 4 means a ceiling level 400 meters, for example. So it goes to the top. What is the bottom? Well, actually, room of this floor of this room is not flat. You see, that is kind of a parabola if you think about it. That is at the bottom. So I put it minus and then the other one. Make sense? Ceiling minus the floor. That's how I do it. So first question was amazing. From 0 to 2, left to right. And then ceiling minus the floor. Yeah, those two questions are a very good match.
Is that it? That's the end of the problem?
No, we need to integrate. But building the integral is the most important part. So I want to be very good explaining this. 4x minus x squared over 2 bar 0 and 2. Plug the top minus the bottom. Plug 2. 4 times 2. Cube, thank you. Good catch. X cube over 3. Minus 2. X cube, minus 2 cube minus 3. Minus 0 minus 0. Right? That's my smiling emoji. And the answer should be positive. It's the area after all. So 8 minus 2 times 2 times 2, 8/3. What is that? I need to count it in Russian. Minus 4 and 4, 16. Yes. The table of multiplication. Surprisingly, you learn it in your own language. Impossible to switch to another language. So I keep having to multiply 3 times 8 in Russian. So can you do this? This is a good problem. Yes.
Are you going to care on the exam if you like write it as a decimal or just a fraction?
Both are good. I don't take points for these kind of things. It's easier to grade if everyone have the same answer. So if everyone give me 0.888, then like boom, grade it. But if everyone have different approximations, someone have a square root, someone has a pi, someone have a decimal, that delays grading. So I prefer people stick to one method which I identify, and when you know which one I like, exact answer. But I don't take points. That's mean if you take points for it. Yeah. I mean, you did good. Good job. Yes.
So how come for the first example you didn't simplify like the 2/3?
I was too lazy. I don't have to. Also, this is for homework. Okay, this is what's for homework. It has 25 and the root. I can do it if you want. This one was easier to do. So I just moved on. You don't have to simplify for homework. And that's exactly the question here was, do we have to simplify? It's fine. I can say you knew. For the exam, that's what they ask. Do you need to do it for the exam? I can see that what you did. If it's good, good job. Yeah. I know many of you are afraid to make a mistake, algebra mistake at the very end. So I'm fine if you don't touch it. Like, I can see what you did. Very good work, 100%. Yeah.
100% for thinking that?
Yeah, I don't mind. And I know how, of course, it's a square root and stuff, but I don't mind. Move on. Besides, you're always out of time, don't you think? So it's nice to move on. Yes?
Where did the 2 and 0?
2 and 0 are these. A and B. So we're going from A to B. And B we found from intersection of 2 functions. This is your homework for you tonight, which was extended from yesterday, so make sure you remember that. Good questions, people, amazing. Let's go back to stuff that we need for the test. I have a list I prepared. And I want to show you definitely some integration skills. Let's review that. Well, any more requests? Let's see. 9:15. What was 15? Let me check. These annoying problems with the written stuff. Yeah, I will do something like this right now. I will do something like this. It might be on the exam, so you better practice that too. Now let's do basic integration. That means you can try to go faster than me and see how it goes. Integration. Who is talking so much again? Integrals. This one, 2x to the 4 minus 4x to the minus 2 plus 5x to the minus 5 plus 3. While I'm looking for my paper, you do it by yourself. And then let's check with my results. Because I have a list of questions prepared. Alright, good. Let's see. Very quick. 2x to the 5 over 5 minus 4x to minus 1 or minus 3. Subtract 1. Minus 2 minus 1 gives you minus 3. Minus 3. Plus 5, x to the minus 6 or minus 4. Subtract 1. Minus 6. Which one?
Positive 4.
This one?
Negative 1 positive 4.
Oh, we're adding 1. Good job. See? See? I'm making mistakes today. Definitely keep an eye on this. Getting too distracted with my news. Minus 2 plus 1. Good job. Minus 2 plus 1. Minus 2 plus 1. Minus 5 plus 1. Minus 5 plus 1. Plus 3x. Good job. Plus what? C. You guys doing fine? How about this one? I think many people stuck with this problem, which is 7 over x minus 1 over 7x dx. How about that? Can you do it? The first one is 7 natural log of x. Do you know that? Because the first one can be rewritten, if you want, as 7 times 1 over x. We know that. How about the second one? The second one can be written as 1 over 7 and 1 over x, dx. So this is the way you can rewrite it first. Minus 1/7 natural log of x plus c. Do you see the difference? So this is kind of more algebra question than integration. 7 over x is 7 times 1 over x. Yeah. Good question. So you always do power rule, which is I did in red, unless you have one exception. Power rule, integral of, let me go in red, x to the n dx is x to the n plus 1 over n plus 1 plus c. It works for everything except one exception, 1 over x. If you have 1 over x, that's the only guy that gives you natural logarithm, absolute value, plus c. So this works for everything except n minus 1, because when n is minus 1, you have a 1 over x. So you can try. A good question. Let me show you this. So this is the answer. Why we cannot do x to the minus 1 with a power rule? You can try, and then you see that you'll get in trouble for this. X minus 1 plus 1 over minus 1 plus 1, right? And you get division by 0. So when you get this, minus 1 plus 1 gives you 0. When you get the 0, it's supposed to hint that it doesn't work. And that's why you use logarithm instead. So that's why it's an exception, to avoid having 0 in the denominator. Yeah. Or just remember, x to the minus 1 or 1 over x is the only function that when you integrate it, it gives you natural logarithm. Yes?
Is it always going to be just x for the inside the natural log?
No. Chain rule is coming. Don't be optimistic. But did I answer your question? Was it like...
So that's so that's for number 3 is just natural log of x.
Yeah. Number 3 is just natural log of x. And that's how you know, because you will get division by 0. So it hints that something is wrong. This is what I wanted to show you. Now let's go to stuff. What kind of stuff? Some kind of chain rule stuff. Your favorite. Chain rule. And we had several shortcuts. What is the integral? So, integral of e to the x dx is e to the x plus c, but integral of ax plus b copy, divide by the leading coefficient. See, dividing by a. Those are my shortcuts. What is the integral of 1 over x? We just had it, natural log of x plus c. But what if it's 1 over ax plus b? You can use your substitution or you perform a shortcut. Natural log ax plus b divided by the leading coefficient works only with linear, only with ax plus b. Finally, what else? Same with ax plus b to the n. Just treat it as a power rule. Ax plus b to the n plus 1 over n plus 1. And divide by the leading coefficient. So the idea is always the same. You divide by the leading coefficient due to chain rule. But let's perform chain rule so you remember how to do it. Chain rule will be on the test. It's already there. Sometimes I will just ask you to choose the character, choose what part should be chosen to be u. And that's it. So sometimes I don't even care to see how you do the integration by parts. Yes?
For the second formula, is it absolute value? Or
Yeah, this one. Oh, this one, no, because it's just a constant and it's not inside of the log. Log should be protected with absolute value, but outside of it is fine. Make sense?
So the ax plus b is?
Ax plus b is inside of the absolute value, yeah. Yes?
For the last one, where it says 1 over a, is there supposed to be like a sign plus or minus, or is that separate?
No, that's a different one, yeah. Just this leading coefficient pops out from U-substitution. Yes? Exponential ones are the best one. For example, write down the example over here. What is e to the 5x minus 7 dx? Copy 5x minus 7 divided by 5. Done. This should be the best problem on the test if you see it. Copy, divide by the leading coefficient. That's how we perform U-substitution, just skipping performing U-sub. I call it U-sub shortcuts. Shortcuts. And usually students love them because it speeds up everything. U-sub shortcuts. Let's do something that doesn't have any shortcuts. Yes? No, we cannot tell you anything, so you just, if you can't do it, but make sure that you know how to do it. Yeah. I like when you do shortcuts. Especially for multiple choice, I don't even know how you do it, right? Maybe you just guessed. But it's good. Like whatever you know, just do it.
So if we do a shortcut, instead of substitution, we'll get.
Yeah, I will like it, yeah.
Well, will we ever have to use the entire process?
Some of it will be, yeah. So you definitely know how to do the whole thing too. Question was here, do we need sometimes to do the whole process? Yes, sometimes you will have to do it, yes.
How many questions are there?
Total?
Yeah.
Same as last time. 8, 6 multiple choice, and 1, 2, 3, 4, 5. And 5 for response, same as last time. Yeah. 3x squared plus 1. Integral 3x squared plus 1 times x squared plus x cubed plus x minus 2 raised to the 9 dx. How about this one? Question number 1, how to solve it? Answer using U-substitution. A, what your choice choose? U. Sometimes I will just ask you, what do you think you should choose, and give you points for choosing correct part to be U. What do you think should be U here? Exactly, this part. Because actually when you differentiate it, it is, okay, you see I missed square. Put square here. 3x squared. It will be 3x plus 1. So just knowing this part is already very important. You made a choice what U should be. You made this choice. Next step, find du, which is 3x squared plus 1 dx. And now you choose the method you like. I like explaining it this way. I need dx multiplied by 3x squared plus 1. And I have it here. So this is a perfect dx. Or another way, do you remember? This is perfect du. Or another way, you solve for dx. If you like this way, do this way. Dx will be 1 over 3x squared plus 1 du. And that will cancel out with 3x plus 1. Let's do this last box is important and the first box is important. B. Integral will be 3x squared plus 1. If you want the method in red, then keep it. U to the 9, and dx is 1 over 3x squared plus 1 du. Cancel out, cancel out. But I like my method more because it's kind of, this is perfect du over here, standing and waiting there to be called du. So the integral becomes u to the 9, bless you, du. That was a very cute sneeze. 8 to the 10 over 10 plus c. But nobody knows what u is. Don't forget to go back. It's going to be x cubed plus x minus 2 to the 10 over 10 plus c. Leave it alone like this. This is a perfect solved problem with U-substitution. What do you think about that? This one was indefinite integral. So let's do also definite integral to make sure you remember how to do these. Did you check everything? Yeah, this is okay. I was confused. I was like, let's do the definite integral now with U-substitution. Yeah, I see it here. Okay, fine. For example, how about the square root stuff? Example 2. Integral from 0 to 1. 15x square root of minus x squared plus 7 dx. How about this one? Step 1, choose u. U, it's natural to have everything inside of the square root to be u because we don't like dealing with square roots. So that is a good point. U is minus x squared plus 7. Why did I do it? Because I'm imagining this whole thing to be a square root of u, and I know how to integrate square root of u. We just practiced that. You guys are talking? Unless you're solving it, you should stop talking. Work hard. This is the last chance to ask very good questions and practice for the exam. Today we're practicing for the exam for the whole hour. Think about that. That's very important. So, du is minus 2x dx. Now see it this way. So, don't get distracted. See it this way. I need x dx. And I want to solve for x dx. This is definitely the way I think is better. Dx dx will be 1 over minus 2 du. I will use the first box and the third box to put in the integral. The first one goes inside of the square root, and the second one will come here, where you have x dx. And now it's not enough. What is missing? 0 and 1 should be changed. 0 and 1 are actually x equals 0 and x equals 1. X equals 0 and x equals 1 now have to become u. But u has a formula, minus x squared plus 7. So I'm using the first box to find new u limits of integration. Minus 0 squared plus 7 and minus 1 squared plus 7. New limits of integration will be 7 and 8, right? Because I should put in parentheses. Actually not, it's not in parentheses. So minus 1 plus 7, which is 6. See the difference? Minus 1 squared is not the same thing as minus 1 squared. That's exactly what here was very important. Minus 1 versus 1. So my new limits of integration will be from 7 to 6. Don't get confused why it's like this. It is fine. Integral will be from 7 to 6. 0 was first, so 7 goes first. And then 1 was after that, so 6 goes after that. 7. Why did I put 0? 7 from 6. Interesting. So, what do I have there? There's a number standing, 15. Don't touch 15, it's there. Now, x dx, that will be this piece, minus 1/2 du. Square root of u, that was planned, we needed that. And x dx becomes minus 1/2 du. Can we solve this integral? Yes. We have all the constant except square root of u, which we will integrate using power rule. Yes.
Why did you get rid of the x?
So yeah, that's the most confusing part here. I was wondering if someone asks. I found x dx like so. X dx now is minus 1/2 du, and I found it from this second line. Remember, sometimes, how do you do your homework? It depends how you do it personally. If you're solving for dx, right, then it will be 1 over x, and it also will cancel out. This way also works. But the goal is you need to get rid of the all x variables and change them into u somehow. That is the goal. We cannot have integral with 2 variables in this class. In upper level classes, we will have that. Yes?
How are you getting a 1/2?
1/2 is this one. Let me show you. I divide it by -2. Let me do like this. I divide it by -2 to solve for x dx. Make sense? So how did I solve for x dx? I divided by -2, and that's why I have minus 1/2 now.
How'd you get the new integrals?
Yeah.
Or, like, why'd you do it?
Let's do this one. I know how one more way to explain it really well. 15 can come out as square root minus x squared plus 7. And then there will be x dx from 0 to 1. If you see this, I just rewrote the terms. It's the same integral. But if you see it this way, this is my u, and this is minus 1/2 du. Perfect match. This is 7, and this is 6. This is how it was converted. The other way around. This is, wait a second. This is how it was converted into the integral 15 squared of u minus 1/2 du from 7 to 6. Each piece was substituted with u using U-substitution. Yes?
So could you just find dx and not x dx?
Yeah. If you like it this way, let me explain it. Good. I can see some students like it, some students don't. So it's makes sense. Different way of thinking. Second line can be like this. You can solve for dx instead. It will be du multiplied by what? 1 over minus 2x du, right? Then when you plug it into the integral, it will be integral 15x squared of u times 1 over minus 2x du, right? And this x will cancel out. So the answer is the same. That means you can do it. Yes, if you like this way, you do this way. You can solve for dx if you want. Solve for dx or solve for dx. Good question, yeah.
I'm just confused why you changed the intervals, like, from 0 to 1.
Yeah, you have to change. If you perform U-substitution, this is the way I was explaining in class that time. This is integral in terms of x. It has dx, and it has x equals 0 and x equals 1. You cannot have integral in terms of u with x equals 0 and x equals 1. Make sense? They should match the variable. So it's kind of illegal to have an integral with different variable when everything inside has a different variable. If the integral is in terms of u, you have to change limits of integration as well. And then we did it this way. We plug into u. So we got 7 and 6. That's one. Kind of U-substitution is a transformation. We're performing transformation of this integral and transforming it into, like transformers, into this integral. Since we're transforming it, limits of integration is where the integral leaves. It used to leave from 0 to 1, that's location. Now it leaves from 7 to 6. You have to change the limits of integration, part of the transformation. So it's transformation, yeah. Or you just get used to it, that you have to do it. More questions? Those are good questions, people. Do you know how to integrate this now? 15 over minus 2, u to the 1/2, u to the 3/2 divided by 3/2, bar from 7 to 6. Because it's square root of u, right? I'm skipping steps since we already did that. 15 over minus 2 times 2/3. Plug the top minus the bottom. 6 to the 3/2 minus 7 to the 3/2. And this is the answer. You just need to simplify it and stuff. Cancel out. Oh, it's actually, this one also cancels out. So it's going to be minus 5. And then you plug the top, minus, plug the bottom, like so. So it is actually a positive number after all, because minus 5 is negative, but 6 minus 7 with power, same powers, will give you probably negative as well, so it will be positive after all. How do you feel about that? Let me check.
So whenever we use U-substitution, we have to replace the both.
Yeah, change limits of integration, A and B. One more thing I wanted to show you. Well, I had lots of things to show you. But how about this one, number 4, I think. Number 7. Yeah. Since we're talking about definite integrals, can you do this one? Example 3. Integral from 2 to b, 2x minus 4 dx equals 9. Can you solve for b? Solve for b. Do you know how to do this one? Solve for b. Step 1, integrate. Finish integration. Don't be bothered. It's from 2 to b. Who cares? It can be from a to b, from a to lambda, from lambda to gamma, your first letter of your name, and stuff like that. From 2 to b, we know how to integrate it. So step 1, left-hand side of this equation. Find that first. From 2 to b, 2x minus 4 dx. LHS is left-hand side. 2x squared over 2 minus 4x instead of plus c. You have a bar from 2 to b. We don't know b, but who cares? Still follow the same procedure. Plug b everywhere, plug 2 everywhere. Equals. It will be 2 cancels out with 2. B squared minus 4 times b minus plug 2 everywhere. It will be, come on, change the color. Okay, good. 2 squared minus 4 times 2. Simplify. B squared minus 4b. This is 4 minus 8. Minus 4 gives you plus 4. Minus. I got this. They want me to find b. How to do that? They gave me the right-hand side. Step 2, right-hand side is given, and it is 9. They told me this gives you 9. So now I can use that and solve for b using quadratic equation formula. Plus 4 equals to 9. So thus, therefore, summary, you know, all those words from GRE exam. International students know. Thus, b squared minus 4b minus 5 equals to 0. Do whatever you know to solve the quadratic equation. I actually did lots of videos about the quadratic equation stuff for my pre-calculus class, so you can check those out. And you will have two solutions here. What are the solutions? Who knows? Yeah? And -1. Very good. And you see you did it fast. That is very good. Always check yourself just in case, but it's really good. You can use quadratic formula or you do the Vieta way, which is factoring. We don't need two. Just a second, let me finish. We don't need two solutions because integral is only from 2 to b. So from 2 to b, we can only choose one solution. So, or like answer, let's call it answer. Answer. B equals 5. Because kind of, I don't agree with the book, how they explain it, blah, blah, blah. Why not choose -1? It is part of the solution after all. But they want integral from 2 to b, so they want it to be consistent that it's a growing number, which is not true. In upper level math, you will learn it's not true, but fine. B equals 5, so they don't want to go down to -1, that's why. But it's kind of a lame thing that they did not explain that part.
So we'd only have to pick one?
Yeah. In general, for the test, I did not put two answers, so just pick the one it's there. More? Let me see, she was first, yeah. Yes. Can you do this problem? How do you feel about this? From 0 to 5. This problem? Yes?
So for like the second part of the equation, when you be like -2 squared minus 4 times 2, is that just solving for like c?
No, this one is when we do the bar. We're going to do solving for c right now. I did the bar and then 2 and b. Plug the top minus the bottom. I plugged b and then I plugged 2. That's what I did. That's the one with the bar. And then right now we're going to do the example with finding c. Yeah. Good job that you remember that one too. More questions? Then let's go the one with the, so let's go with the one we just mentioned, solving for c. This one I just copied pasted the exam because these are nice questions and I gave them on the quiz, if you remember, for a reason. Number 2 from the review, example, initial value problem. That's how I call it everywhere, so it's nice like to tell you this is initial value problem. Why? Because it has an initial value or initial information. Bless you, 9x squared, no. 9e to the x plus 9. But that is not the original function. That is a derivative. And they want you to find f. If you just integrate, you will have plus c, which is infinitely many solutions. So they tell you, well, actually at 0, it is -1. Don't always assume that -1 is your c. It's not the case, actually. You have to calculate it. Solution. This problem might show up several times in the test called initial value problem. Step 1, integrate whatever we gave you. 9e to the x gives you 9e to the x. 9 gives you 9x plus c, right? And now they tell you, well, actually, I need you to plug x equals 0 and use that function equals -1 at 0 to find c, to solve for c. So it's going to be 9e to the 0 plus 9 times 0 plus c equals to -1. Solve for c. The thing is, remember, e to the 0 is not 0. It's 1. So that's why you should be careful with that. 9 plus 0 plus c equals -1. c is -10. So answer. Can you do this? If it's multiple choice, can you choose it? Or if it's written part, can you write it down? F is 9e to the x plus 9x minus 10. That is the answer. Can you do this one? This is a very nice short problem, so that's why they put it twice in the exam. Just like I put it twice on the quiz. It might be hidden as the applicational problem. So review number 2 and number 4. Those are the same problems, I will show you. Those are the same problems, but one has like background story behind this thing, which is the function gives the total cost of the product. The marginal is given. Marginal is derivative of the total cost. Here's the function. And we also know that at first unit it is $5. So integrate and figure out. Just the same way, you integrate step 1, you integrate, put plus c, and then you use at unit 1, it gave you $5. Set it equal to 5. Solve for c. The code k doesn't matter. It's not internationally chosen to be c. Solve for c and you got your solution. Can you do that? So it's the same idea but hidden behind words. I know English as a second language students always hate this way because it's lots of reading, but it's exactly the same problem. Look how short it can be written versus how much explanation there is. That is because we wanted to understand business applications of this idea. Initial value problem, marginal is given, initial value is given, find the cost function. Same with velocity and acceleration. Also, velocity is given, right? Say x squared plus 5, and distance at 0 is 17. Find s of t. This same problem. So all of these are the same. They just have different wordings. Review number 2, number 4, and these velocity things, because it's exactly the same idea. You integrate velocity, plug in 0, set it equal to 17, solve for c. What else is here? So we did this, 8, 7, 8. Riemann sums. How do you feel about Riemann sums? Not too bad or like eh. Number 8. Riemann sums or rectangles. Number 8. Calculate the Riemann sums for the given function on the given interval, and I give you number of intervals. So let's do that one. Number 8 is a really good one. Function is given, f of x is, I can just write here, 3x squared plus 2x minus 3. Interval is given 1 and 3, and n is 5. Calculate using Riemann sums. Using what kind of Riemann sums? Left or right, we give you. So you have to figure out, you need to know both, but we give you one. And that's why on the quiz I asked you to find both. Left and right, be ready to do both. Solution, left Riemann sums. Solution, the step 1 is always the same. Find delta x, that's the step size. Step size. Delta x has a formula, b minus a over n. N is 5, we give you n. A and b, we give you that as well. So it's going to be 5 minus 1 divided by 5. The interval is 3. 3 minus 1 divided by 5, which is minus 2 divided by 5, which is 2 divided by 5, which is 0.4. Or you can keep it as a fraction, 2/5. Now, remember, if you use left Riemann sum, they're called L sub 5. Those are left ones with 5 sub-intervals. Then you're using the first point, and you can sketch the graph. Here it is from 1 to 3. I have 5 intervals. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The step size is 0.4, so it's going to be 1.4, 1.8, 2.2, 2.7, whatever. Sorry, it didn't match. 2.6. And how did it get to 3? Oh yeah, and to 3. Okay, works. So for the left sums, I'm using these left points. They're literally left end points of the rectangles. For the right sum, I skip the first one and use all the right ones. So for the left sum, check this out. I will do like so. Factor out, you always do it for both sums. L sub 5 is factor out 0.4 brackets. And now you have f at 1 plus f at 1.4 plus f at 1.8 plus f at 2.2 plus f at 2.6, and you skip f of 3. Those f's should be 5 because we have n equals 5.
Go to the left.
That's left one.
Was it sigma? How was the notation?
For the left one, what?
And
N is 5, we gave you, right?
so, but it was an n minus 1. It's just n to the left hand itself.
I know what you're asking. Yes, n starts from 0 to n minus 1. Yeah, for the left. And then for the right, it starts from 1 till n. Yeah. I usually like explaining it visually. We go to all the left points. Use left points. That's how I explained. For the left sum. And now you plug these into the original equation using your calculator. Plug, 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 and plug. And you get the number. So it's going to be 0.4, and there's a 2 plus 5.68, blah, 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 blah. Simplify to 256. Can you do that? So you plug. Step 1, find delta x. Step 2, understand which points to use. Step 3, build your left sum or right sum. Step 4, plug values into f, which is original, right? The original function given. And calculate, and you will have a finite number, and it should be a number. What do you feel about this? Practice this one, and kind of that's what I'm gonna put there, but that's not it. Let me have last 10 minutes. Let's see what else I want to show you. But tell me, what do you feel about this? It will be one problem on the Riemann sums, at least one. I don't like those topics at all, and they always teach it exactly in this exam once. So they always want to put it on a test. Finally, let's see. Yes? Huh? Let's do right. That's a good question. Let's do right, Sam, just in case. I just wanted to move on. Let's see. Right will be still 0.4, but we skip the first one. It will be f 1.4, f 1.8, f of 2.2, f of 2.6 plus the last one, f of 3. So for the right endpoints, we're using right endpoints of the interval, which is this one, this one, this one, this one, and the last one. Make sense? So for the left one, skip the last one. For the right one, skip the first one. Make sense? So at the end was here, you skip the last one.
So, why do you write it L6?
1.4, 1.8, 2.2, 2.6, f of 3.
No, L6. Why that?
Oh, thank you. That was fine. My tablet is glitching because it's of the... Oh, and it's also not L. My tablet is glitching, and I think it's copying. because I am running the recording program, so it's glitching it. Good question. What else I wanted to show you? We kind of reviewed lots of important things. Finally, one more thing I wanted to show you was, oh, very good actually. We covered almost everything. One more thing I wanted to show you are those long problems which are from your homework right now. What are those including years? You know, they like to tell you some backstory, and then they tell you, oh, but figure out from 2004 to 2006. You said on your homework. Let's do that. That is problems. Oh, and average value. Average value will be your favorite chapter. So we in office hours today we were talking about this. So let me quickly tell you that average value problem on the exam will be the best one. Do you know why? I ask you to find average value for f of x equals 6 e to the 0 point x on minus 1 to 3. Do you know what you have to do? Integrate and divide, but just a second. Integrate and divide by the interval. Oh, thank you. Do you know what we have to do when they ask you to find average? I got too excited. Integrate and divide by the length of the interval. Average. Well, I didn't call it A in your book somehow. I don't know why. It will be integral from minus 1 to 3, the function they gave you, and then you divide by the b minus a, 3 minus 1. Because the formula for the average value looks like this. Integral from a to b, f of x dx, 1 over b minus a. That's it. So there's no information here. You just need to not to forget to divide by the length of the interval. That's why it's going to be the best problem there. Yeah, another question?
I thought 14.3 wasn't on.
No, I put it in the, that's why the homework is still there. Yeah, I put it in the list, in the announcement. Check the announcements. How come you don't check the announcements? But didn't you see there was homework for 14.3 due today? Come on, people, this is very important. There was an announcement called exam information. Did you read it? Also, it says important. So I kicked out, I remember I told you, I kicked out one chapter that was 14.1. Because that one is harder. I was debating between leaving that one or this one. I cannot kick out two. That one is very hard, so that one will take weeks to learn. Average, I just taught it in 5 seconds. This is not something new. It's just integral divide by the lengths. I pushed. Let me show you this, and I'll show you one more example in 5 minutes. Please read my announcements. How come I can see now you don't read my announcements? It says topics, and it says please read. And then 3 or 4 exclamation marks. What is this? It's here. And what is this? It says that averages. Why did we cover it in the class then if we did not need it? We covered it last time. At the very end, check the notes. I was dividing by b minus a. Because it's not feeling like a new material. That's why I don't remember. At the very end, if you check, that's why maybe you don't feel it. Interval 1 over b minus a.
It's because you didn't say it was 4.3.
Oh, maybe. Yeah. Write it down. It was 14.3. 14.3.
I think you just went
I just showed it as an extension. Okay. 14.3. So check out that we did do it. Yeah. Maybe you did not write it down. It was 13.3. 14.3. But again, whatever you see here is, that's all you need to know, just the formula. One more thing, or you guys want to go? As you wish. I don't have preferences. One more thing you can check at home is this one. Let me show you. This one, you can do it by yourself if you want to go, because I don't want to force you to stay here. Some kind of life problem with the years. Find it in your homework and check this out. When we give you years, What does that mean? It means I will ask you to integrate, and then instead of those years, you will use values for the year. Something starts from 2005. Maybe you don't see it. Let me show you bigger. Nope. Make it worse. Something started in 2005, so 2007 will be 2, and 2010 will be 5. Integrate the function I gave you, done. This is one-step problem, but you need to read it. I would say we give you years. That's how you know this is the problem. You integrate and put the values, what they explain you with years. So this kind of problem is on a test too. That is 14.2, I think. So okay, now it is official. It is in the recording. 14.3. Not only it's your homework due tonight, which has only a few problems, so it's not too bad. But it is only one extra step from the material we already know, which is this one. Yeah. See you on Thursday, people.
As long as we know
Yeah, maybe so.